Alrighty, an actual daily that is at my usual hour. Okay, minimum swaps to arrange a binary grid medium. Return an n by n binary. You're given an n by n binary grid, square grid. In one step, you can choose two adjacent rows of grid and swap them. A grid is said to be valid if all cells above the main diagonals are 0. Above the main diagonals are 0. Return the minimum number of swaps needed to make the grid valid, or -1 if the grid cannot be valid. The main diagonal is the diagonals that starts with 1, 1 and ends with n, n. All the cells above the main diagonal, so it has to be the upper right corner. And you can swap cells. You can choose two adjacent rows of the grid and swap them. Okay. So here you swap the first and second, and then the second and third. First and second. You need this 1 to be at the last row. First and second. So this needs to go down twice. And then the second and these two need to swap. So 3 swaps. Okay, sure. Here, I think it's impossible because this column's all 1s. So there's never a way for this column to ever have 0s above the main diagonal. And obviously this one's already valid. Okay, so logically what needs to occur, you need to move for a particular row. There's a 1 in this last spot. The only row that it could be in is the last row. Or the last row. I feel like this might be a greedy approach. You have to feels like this would be a greedy approach. You move columns to the first column. You move rows to the first row that it can work. So this is the first row that this would work. This 0, 0, 1 would be the third row, because it wouldn't be able to be above the main diagonal in the first 2 rows. So this becomes the third row, and then you move the other 2 up. And then you have to swap the first and second row at that point in order for this 1, 1, 0 to be in the second row. Is that right? So what if you had 0, 0, let's say you had 0, 1, 0, 0, 1, 0, maybe 0, 0, 1, 0, 0, 0, 1, 0. What if you had something like that? So the first row that this would work in would be the third row. So it has to move down twice. And then this one would have to be This one would in theory be third row as well. Huh. So if this you're starting, you move this thing down twice. Seems okay. Seems like it might be bad to try a greedy approach. You'd end up with something like 0010, 0100, 0010, 100. If you just move the first row down 2 so that this 1 is in the third row, then this one also would want to be at least the third row, so the fourth row. Okay, maybe what I need is for each row, I identify the earliest row it needs to be. It could be, so the first row could be in the third or fourth row, the second row could be in the third or fourth row, based on pretty much where the first one occurs, right? The second row, this third row can be in the second, third, or fourth. Okay, so how many steps to move this thing so that the number itself is in a spot that is at most that number, one indexed base? How many moves? So I can only do swaps. Adjacent swaps. I mean, in theory, if you look at this, the thing you should probably do is like swap the 1, 2, and then move the 3 back, move. What would you do here? You'd move the 1 up to the first, and you get 3, 1, 3, 3, 2, and then you move the 2 up. So the 1 would need to move 1, 2, 3, and the 2 would need to move 1, 2. So that would be a total of 5. I think any other way, like moving the 2 up, moving the 1, I think 5 is just. Okay, what about the greedy approach here? So 3 needs to move. I'm not even sure how you do the greedy approach. 3 in theory needs to move here, but then this 3 would then move up. So you'd have 3 moves back. So you get 3, 3. No, you get 3, 2, 3. At that point, you need to move the second 3 back. So it'd be. Then the other 3 gets bumped up. Yeah. Okay. Maybe what I should do is actually. Maybe I'm thinking about this wrong. I should be maybe thinking about, instead of moving the first element up or the first element back, I need to move other elements to the front, because that'll help make everything correctly ordered. So the 1 moves up 3, get 1, 3, 3, 2, and then 2 moves up Okay. And then the element that moves up would be what? It would probably make sense to move the earliest element that satisfies the place. So the one spot needs something that could be one spot. So for instance, if it was something like 3, let's say 3, 4, 5, 2, 1, 1. So I would move this one up first and get something that is 1, 3, 4, 5, 2, 1. And that'll be moving 1, 2, 3, 4. And then I move the 2 up. So that'll be 1, 2, 3. So that's total 7. At that point, everything works. So I need to find the earliest row that satisfies the current row and move that up. Kind of a greedy approach in that sense. How would I identify that? Because in theory, if I'm at row 2, then anything interesting. If I'm at row 2, then I need to find the earliest thing that is 2 or less. Your earliest thing that's at 2 or less. So I feel like this involves sorting. So either sorting or a heap, maybe. If I sort, if I make a tuple list, oh, how big is this? 200 rows, okay. If I make a tuple list where the tuple list is the earliest row it could be and the index it currently is, the current row it is, and the earliest row it could be, then I iterate. It would just be I think it'd be a heap. If I kept a heap of the earliest row something is, the earliest row that I see a value that's less than the current row. Earliest row, it'd be a sorted, I would need to have a sorted list and then a heap. Sorted list to find the earliest row of something, and then a heap to pull out the earliest row. Alright. I thought I was pretty sharp right now, but I'm getting more and more confused. So I think what I want is to identify for each row the earliest, like the earliest row that it could be. Like 0, 0, 1, 0 is the earliest row it could be is row 3. It could be row 3 or row 4. 1, 0, 0 This row could be rows 1, 2, 3, or 4. So that's based on where the first non-zero value in that row is. The first one in that row. So let's say for every, I need to keep track of the row index. So length of the grid is n. I'll say earliest is an empty array for every index in range n. Let's say the row is grid at n. And then I need to find where the first one is. Let's say first is going to be 0. Actually, or sure, first in range n. If row at this index is equal to 1, break. So this index should be the index where I find the first one, possibly equal to n if I don't find a 1 in this row. So I'll say this is earliest, appends this tuple. This tuple, I think I need to put first and then the row. First and then the index, the row index. Yeah. So here, the earliest is going to track tuples, earliest row, current row, where this is indices. For example, 0, 0, 1, 0, where n is equal to 4. If this is the first row, then the earliest this could be is row 3. Actually, I'm doing this based on index 0 index, so 2, 0. So the earliest row, the earliest index I can make this is index 2, and it's going to be currently the 0 index row. Okay, so I think at that point I can sort. Yeah, I think I can sort. And then I can do something like I need to have a heap, I think. And then for every row, let's say index row in range n, add to the heap, add to heap all possible rows, add to heap all possible rows. So I think it's going to be while I think I need an early index maybe. Or I can make the earliest thing, I can make that a delimited queue. Or I can sort it backwards. I think I can sort it backwards actually. Yeah, so I can just look at the last thing in the earliest and then just pop it. Then I don't need to have an index. I'm going to append a dummy to make sure that the earliest never gets to 0. So dummy would be infinity maybe. So that should be the first element in the earliest. It's just I don't want to have to check if there's actually an element in earliest while I pop it. So while earliest, the last element of this has a row that is less than I think it might just be equal to the current index row. Heap appends, actually it'd be heap push onto the heap just the value of the earliest of the current row it's in. So earliest, the first value. The last element of the earliest array, the current row it is in, and then earliest pop. Okay. And then now I find the best one to swap. So if there's an empty heap, then that means that it's not possible. Otherwise, I'll do something that is answer plus equals the difference between whatever the smallest current row is, the smallest element in the heap versus this index. And this index is probably going to be this index should be what's subtracted by. So I think it's going to be heap pop heap. Actually, yeah, I think it's heap pop heap minus the current index. I think that might be it. Index out of range, row equals grid n. Oh boy. List appends takes 2 arguments, takes exactly 1 argument. I'm supposed to append the tuple. Oopsie. First index. Looks like it went infinite, maybe? Interesting. Alright, let's go ahead and just start off by printing out what the earliest has. It seemed to take a long time. Okay, so this one earliest row should be 2, current row is 0. Earliest row for this one is row 1, current row 1. Okay. Yeah. Okay. Yeah. My logic for what the earliest row is, it's wrong. So it should be the last one determines where it needs to be. Right, the last one. Because the one here being the last spot means that it can't be in rows 0, 1 indexed. So I need to go backwards rather than forwards. So for every row index, and then, yeah, so it should be from n minus 1, negative 1, negative 1. So this is the first index where I see a 1 backwards. Sure. Okay, let's double check that. Okay, so this row is first row, this should be is number 2, row 1, row 0, and it's currently row 2. Okay, that's fine. So this is all good, to be honest. Yeah, I see, I see. Okay. Yeah, I see. So the issue is, well, I'm not sure how this is 0, to be honest. So it goes through, should at least gotten 2 here, moving this thing up from row index 2 to row index 0. So, well, earliest, the last element of it, so it should have, gone 2 on the first go. Okay, so this is 2. I'm not sure why the answer didn't. Heap, pop, heap. Does this not return 2? Uh, would be 2. Okay, so it is 2. Interesting. Yeah. So it goes 2, and then the next pass 1. That doesn't change anything, I don't think. And then the last pass it went -2, I think. Yeah, it went -2. So my math is somewhat wrong. Because if I shift this up 2, then these ones technically become 1 and 2. So they don't have to actually move. They definitely don't move in a negative number of swaps. Technically this one does need to move. This no one becomes 2 at that point. So how to model this? So I need to move 2 up, and that means that everything else, everything between 0 and 2 gets changed. This thing becomes basically row 1, and this becomes row index 1, row index 2. Gets bumped back 1. So close, so close. So find the earliest that I need to move up. Find the earliest that I need to move up. And then somehow track that. Track that maybe. Because if the earliest that needs to move up by 1, there was like another row that was like after it. Let's say like this was 0. I'm not sure what I'm thinking of. So this one needs to move an additional 1 because this thing gets bumped back. But if it was after the 0, 2, then there wouldn't be. I'm always pulling the earliest. Always pulling the earliest. When I pull the earliest, this thing scoots back. Everything between the row that I'm pulling it to and the row that I'm pulling it from gets changes their relative position. They move back, increasing their row index by 1. Doesn't change the row that they can move to, but does change the current row that they're in. So if I move this row 4, 2, then this row becomes row index 1, row index 2. Row index 1, row index 2. How would I track that? How would I track that? If I don't want to... What do I want to do? Could keep a list. No. Pair which rows I'm pulling it from. Well, I mean, in theory, given that this is n up to 200, it doesn't need to be very efficient in order to solve something that size. Could simulate actually adding rows. I'm in row 1, pulled something from row index 2 up to row index 0. So hold something up here. So something like 3, 0, 4, 1, 5, 2, 2, 3, 4, 1, 1, 4, 1, 5. So the first pass at row index 1, 4 and 5 gets added to the heap. I pull row 4. It takes 1, 2, 3, 4 swaps to get to the front. So the heap becomes just 5. And then next time at row index 2, I would add 3 and in theory add 3 to the heap. But since I already pulled from 4, then this 3 needs to go back 1. If I'd pulled from something earlier, this 3 doesn't go anywhere because it's still relatively 3. 4, so in theory this would move. Yeah, so it'd be something like heap is maybe 4, 5 at that point. Because this would be at row 4 at that point. This is still row 5. And then I pull another row 4. but this time to row 2. Then the heap is after that, row 5. And then the next pass, when I'm at row 3, this thing technically would be, this thing would be 2 at that point. Oh my god. Hmm. Hmm. Row I'm at compared to the current row that's at. Current row I'm at versus the current row that thing's at. No, that's not it. It's the current row I'm at versus the number of rows that are bigger than, that are after the row that I'm pulling, that I'm comparing to. I think. Current row that I'm at. Right. Current row I'm at versus so the 1, 4 moves past the 2, 3. This 1 moves past the 2, 5, 4, 3. And becomes 1, 3, 4, 5, 2, 1. This 2, this 5, this 4, this 3 changes their relative position. Interesting. Wonder if this is just, rather than sorting it, wonder if this could be done with a sliding window or some sort of asymptotic stack or monotonic stack. Monotonic stack. Monotonic heap. So on the heap is 3, 4, 5, 2, 3, 4, 5, 2. Interesting. So if I actually just did a pass of the array, keeping track of the row, the earliest row that something could be. So I keep track of the three. The first row, the earliest row could be is 3. Row, the latest row here is row 4, row 5, row 2, and then finally I hit something as row 1. At that point, I could say that all these rows have a position that is +1. Maybe they have a default position that's +0. Interesting. So this 3 needs to have 2 at least pulled before it. And there can't be more than 2. It has to be exactly 2. Because it's the earliest 3. Because this is the earliest 3. Interesting. This 3 is guaranteed to be the 3 that I eventually have. Because when 2 other things get pulled before this 3, this thing will be in the 3rd spot. Same thing with this 4. How do I know that that 4? Like for instance, if this was like 3, 4, 1, 1, 1, like just a bunch of ones, I know that this is going to be my eventual 3, this is my eventual 4, this is my eventual 5, and then just these first 2 needs to be pulled in front. Huh. How to keep track of that? 3, 4, 5, bunch of 1s. So I put 3 in the stack, 4 in the stack, 5 in the stack. I see a 1. One does what? 1 moves to the front, and then somehow the stack, I do some sort of reduction on the stack. Reduction on the heap, because maybe this is, what if this was 5, 4, 3? Reduction on the heap. So this 1 gets pulled in front, 5 gets added into the heap, 4 gets added into the heap, 3 gets added into the heap. I see the 1, I know that I need to pull this 1. See the 1, I need to pull the 1. Swapping with everything that's currently on a heap, so swapping with the 3, 4, 5. So the number of swaps is the number of things on the heap. Right. And then the next one I'm at row 2, or I'm trying to slot to row 2. Try to slot to row 2. 3 is on the heap. So it has to be the next thing down. So this thing gets swapped, and the heap is size 3 again, so it's going to move 1, 2, 3 up. And then what happens with the 3? 3 technically needs to move past the 5 and the 4, so even if it's on the heap. So I would take, so current index is 3. Or so I take the values, current index, plus the number of swaps. That'd be like 1, 1, 5, 4, 3. So 3 move down 2. Then it 3 move down 2. Then it needs to go back to 3. So this thing needs to swap 3 times. 1, 2, 3. This thing needs to swap 3 times. 1, 2, 3. And then this thing needs to swap how many times? Do 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 do. 1, 1, 3, 4, 5, bunch of ones. So in theory, the 3 could be in the right spot already, or could need to swap with other things before it. So it would be basically depend on the previous row it's at. Three was previously at row 0. Here 3 is previously at row index 2. Or what if it was 4, 3, 5, 1, 1, 1, 1, 1, 4, 3, 5. So here was previously at row index 1. Is it just the previous row index? Is the number of swaps it would need to be? Why would that make sense? What? So then this would be 1, 1, 3, 4, 5. So I'm at row index 2 versus row index 1. There had to be 2 things that pushed it. So it'd be the previous row index plus the number of things that I've filled. Which is equal to the number of things that to the current placement, I think. Yeah, equals the current placement. So this being at index 1 means that I need to basically swap 1. And then 4 being index 0 means I need to swap 0? How does that work? Can't be right. Four is at index 1 there. Three, 4, 5. Swap 1 up, 1 up. Then 3, 4, 5 is on the heap. Three gets shifted back to 4 is on the heap. 4. Right. Wow. I've been on a horrible run of solving these. Just stumped. Alright.